Hi guys, welcome to a lesson on polynomials. All of you have probably been introduced to this chapter in grade 10, but one of the most important parts of this chapter is when you have to understand how the graph of a quadratic polynomial looks like, which is what we're going to focus on today. So this short video is going to help you understand every single thing you need to know about how a graph of a quadratic polynomial is going to look like. Now, before we begin with all that, let us try and understand what a quadratic polynomial is. Now, we all know that a quadratic polynomial is represented by, in its standard form, is represented by f of x equal to ax square plus bx plus c. This is how a quadratic polynomial is represented. But an important condition that you always have to remember is that this value of a should never be equal to 0, because if this value a becomes 0, then this whole term vanishes, and if that whole term vanishes, you're just going to be left with bx plus c, which no longer makes it a quadratic polynomial, because for it to be a quadratic polynomial you must have an x squared term. Alright, or the highest degree should be 2. If a becomes 0, then it becomes a linear polynomial. Alright, so whenever you write this, don't ever forget to write a not equal to 0. Now, at this point in time, if a quadratic polynomial is given to you, and if they ask you to find out how many zeros it has, all of us also understand that depending on the degree of the polynomial, you will be able to predict how many zeros it may have. Now, a quadratic polynomial has a degree 2 because the highest power here you see is 2. Since the highest power is 2, you're going to have 2 zeros. Now the next question is, what is the meaning of this word 0? 0 indicates the maximum values of x you can obtain after solving it as an equation. For example, if I take a quadratic equation like this, x square plus 5x plus 6, and if I make it an equation by equating it to 0, and if I ask you, can you tell me how many values of x can this equation satisfy? You're going to tell me that the answer is 2, because when you have to solve this quadratic equation, what will you do? You will split the middle term. When you split the middle term, you're going to get x square plus 3x plus 2x plus 6 equal to 0. I'm going to combine these two. So I'm going to get x into x plus 3 plus 2 into x plus 3 is equal to 0. Now I'm going to take x plus 3 common. I'm going to get x plus 2 equal to 0. So if the product of two terms is 0, it is very clear that one of them has to be 0. So in the first case, I'm going to take x plus 3 equal to 0. So I get x equal to minus 3. And the other value is going to be x plus 2 is equal to 0, making x equal to minus 2. So here you notice that when I solve this quadratic equation, I'm going to get two values of x. These values are called as zeros. Sometimes they are also called as roots. So whenever you solve a quadratic equation or a quadratic polynomial, you are going to get two values. Generally, the first value is denoted as alpha and the second value is denoted as beta. So next time, instead of saying x equal to something and x equal to something, I can directly say that a quadratic polynomial has two zeros. One is called alpha, the other is called beta. Now that we understand how to split the middle term and do all of that, the next obvious question is, how does the graph of a quadratic polynomial look? Now, before we go there, let us understand the difference between a polynomial and an equation. If it is written in terms of a function, say f of x equal to something, then you call it a polynomial. But if you write the quadratic polynomial and say it's equal to 0 or equal to some other constant, then you say it is an equation. An equation should have an equal to sign and it's equated to something else, which is why it becomes an equation. Okay, so at this point in time, we are not going to deal with quadratic equations. We are only sticking to the concept of quadratic polynomials. And having said that, let us try and understand how the graph of a quadratic polynomial is going to look. So for that, I'm just going to write the heading first. Graph of a quadratic polynomial. Now let us try and understand how this is going to work. Now, we know that a quadratic polynomial has two zeros, which we just derived. First one is called alpha, second one is called beta. These are my two zeros. Whenever you plot a graph for a polynomial, depending on the number of zeros it has, the graph is going to take a particular shape. Correct? Now, for a quadratic polynomial, the graph is always going to look like a parabola. Now, what is a parabola? A parabola has a U shape. It could be like this, or it could be like this. It could be an opening U upwards or an opening U downwards. Now, this is how the shape of a quadratic polynomial is going to look when you plot it on a graph. Alright? The next thing is, without having enough information or without really necessarily plotting a graph, can you still predict how your graph is going to look or where you can place all the points on the graph? The answer is yes, which is what we're going to do right now. The first thing that I want you to understand is that the graph of a quadratic polynomial is going to resemble a parabola. Now, whenever you plot a graph, the first important thing that you need to put is the representation of the x-axis and the y-axis. So, the x-axis is going to be x, the y-axis is going to be f of x. Now, when you say f of x is equal to ax squared plus bx plus c, this value of x that you're going to put is going to be on the x-axis and this is going to be on the y-axis. Okay? Now, again same thing here, this is going to be x, this is going to be f of x. Now, let us try and understand how this graph is going to look, because our session today is primarily focused on this. Okay? Let's take a very simple example. The only thing we know right now is a quadratic polynomial when plotted is going to look like a parabola on a graph. Now, parabola, I told you, can be upward opening, downward opening, depending on how we look at it. Okay. So, let us look at how you figure out whether it's upward opening or downward opening and all of that. Now, the first thing that I will do is, I will take a simple equation. Let's take example 1. F of x equal to, say, x squared plus 5x plus 6. Let's take the same polynomial that we had used a while back. Now, the first thing I'm going to check is the first term. That is my first step. I'm going to check my first term. What is my first term? My first term is 1x squared. If there is no number next to it, assume there is a 1 there. It is 1x squared. Then what I'm going to do is I'm going to check the sign of this. Is this positive or negative? What I notice is that 1 is positive. If it is positive, it means that the graph is upward opening, which means the graph is going to look like this. It is going to be upward opening. Okay. In case I had a minus sign here, then it would have been a downward opening graph like this. Okay. Now, since it is positive, it is going to be an upward opening graph. Okay. Now, let us try and figure out a little thing about this. I know this is x. I know this is f of x. No problem. Now, you notice that the graph is crossing the x-axis at two places. The first value is going to be alpha, the second value is going to be beta. Wherever it crosses the x-axis, it indicates that that is the zero of the polynomial. Now we know that when we solve the polynomial, we got two zeros. Whatever the zeros are, we'll change the graph accordingly later. But depending on the number of zeros you have, it will cross the x-axis that many times. Alright. Now, let us next find out a little more interesting facts about this. Do you notice this point where it peaks? This is the value, this is the maximum value it takes before it starts going up again like this. This position is called as the vertex. Now let us try and understand how you can find out the vertex as well. To find out the vertex, there is a special formula which is given by minus b by 2a and minus d by 4a. Now, what is b, what is a, what is d, what is a? I will tell you all that right now. We know the quadratic polynomial is ax squared plus bx plus c. So here my polynomial was x squared plus 5x plus 6. So when I compare, I notice that my value of a is 1. I know the value of b is 5 and I know my value of c is 6. So I know the value of b, I know the value of a, these values I have already found out. Now let us find out what this d value is. D is called as the discriminant, which you are also going to learn in quadratic equations this year. Discriminant is given by the formula b square minus 4ac, which means I'm going to put these values, a, b, c values in this and then find out the value of the discriminant. What is the discriminant going to be? B square is going to be 5 square minus 4 into what is a? 1. What is c? 6. So I get 25 minus 4 times 6 is 24. So I get 1. Now that I have the values of a, b, c, d, all of that, let me put this value and let me keep the position of the vertex also ready. So I'm just going to show that calculation here. We know that vertex is, let's put that there, vertex is given by minus b by 2a. What is minus b? Minus b is minus 5 by, what is 2a? 2 into 1, which is 2. I'm just substituting the values a, b and all of that. Now I have a minus d. What is the value of d? I got the value of d as 1. So wherever minus d is there, I'm going to put minus 1 divided by, what is 4a? 4 into 1, which is 4. So here what I got was a vertex value, coordinates of the vertex. So wherever I see the point minus 5 by 2 comma minus 1 by 4, the graph has to peak. Okay. So I found out where this has to be. I found out that the coordinate has to be minus 5 by 2 minus 1 by 4. So what I'm going to do now is I'm going to start writing everything down in one place. The first thing I know is it is opening upward. Okay. The second thing I know is that the vertex, if you see, is minus 5 by 2 minus 1 by 4. And what I've also found out is the value of alpha and beta. I already found it out here if you remember. It was minus 3 and minus 2 for the same equation. I picked up the same equation. So minus 3 and minus 2 were the zeros. So I'm just going to go back there and say 1 is minus 3, 1 is minus 2. So having said all of this, let us try and see how the graph is going to look. 1, I told you it is going to be opening upward. So my graph is going to be like this, where it crosses the x-axis at points minus 3 and minus 2. So if I take this as my graph, where this is f of x and this is x, I know this is my origin. This is going to be minus 1, minus 2, minus 3, extend a little if you want to, minus 4 and all of that. I know my graph has to cross at minus 3 and minus 2, which I'm going to mark here. So I have a minus 3 here, I have a minus 2 here, okay, and it is going to be opening upward. So my graph is going to look like this, okay. So this is how my graph is going to look, and wherever you see the vertex, the coordinates of that vertex should be minus 5 by 2, minus 1 by 4. And you notice both these values are negative, and it is clear that this is in the what. This is how you find out how your graph is going to be when you plot it on the axis. So if you have understood this concept, let us take a few more examples to try and understand how graphs of a quadratic polynomial may be interpreted. As of now, what have we understood? We've understood that whenever you write a quadratic polynomial like this, the first step is check the sign of A. Again, if it is positive, like the way we had in the previous case, then it is going to be an opening upward graph. And in case I have a minus, then it's going to be opening downward. The next point is find the vertex. How do you find the vertex? You use the formula minus b by 2a and minus b by 4a. Okay, now we know what your a, b and c etc are. B value you can directly get from here. A value also you can directly get from here. In order to obtain D, you need to use B square minus 4AC formula. ABC values you can directly get and obtain. Once you have the vertex, keep that aside. And the third thing is, find out alpha and beta by splitting the middle term. And then find out where it has to come in the graph. Okay. So I will take one more example for you, and then I'm sure all of you will be able to pick it up. So let us take the next example. I'll just put it up for you. F of x is equal to x square minus 2x minus 8. Okay, let's go a little slow on this. If you've forgotten, just go back to the 3 steps I gave you on the previous page so that you can understand it better. The first thing is, I told you, you need to write it in the form of ax square plus bx plus c. The first step is, I check the sign of a. I notice that the value of a is plus 1, which means it has to be upward opening. Done. The first part is done. So my graph is going to look like this. Now I need to find out where it is crossing the x-axis and where the vertex has to be. Okay. So the first part is done. The second part is, let's find the vertex value. Vertex is given by minus b by 2a and minus b by 4a. Sorry, I'll just write this properly. Minus b by 4a. Let's find that value. Now, as of now, I know the value of a is 1, the value of b is minus 2, the value of c is minus 8. Let's put the values here. So, minus b by 2a. What is minus b minus of minus 2? 2a is going to be 2 into 1, which is 2, comma. I have not found out the value of d. Let me quickly find the value of d. I know the value of d is b square minus 4ac. What is b square here? Minus 2 the whole square. Minus 4 into 1 into minus 8. So I get 4 plus 32. So this is going to give me 36. So the value of d is going to be 36. I'll put that value here. So minus d is going to be minus 36 divided by 4a. A is 1, so 4 into a is 4 into 1, which is 4. I'll simplify this. Minus of minus 2 is going to give me plus 2. Plus 2 by plus 2 is going to give me 1. Minus 36 by 4 is going to give me minus 9. So at the coordinates 1 comma minus 9 should lie the vertex of this graph. And the next obvious thing is, I need to find out where it is crossing the x-axis, for which I need to find out the values of alpha and beta. I will do that by splitting the middle term. So my first step is done, it's opening upward. My second step is, I know where the vertex is. The third step is where I need to find out the value of alpha and beta. So for that, I will do that working here, and let's see how we can find out the value of alpha and beta. Now we have to split this. You have to get factors of 8, that is going to give us 2. The factors of 8 that is going to give me 2 are 4 and 2. So let's split it. So I have x square minus 2x minus 8 is equal to 0. So I'm splitting it now. X square minus 4x plus 2x minus 8 equal to 0. Take a common factor here. X into x minus 4 plus 2 into x minus 4 is equal to 0. Now you take x minus 4 as common. So I get x plus 2 equal to 0. So when I try to find the value of alpha and beta, the rest of it I will do here. I get x minus 4 equal to 0. So I get x equal to 4, which is going to be, call it alpha. Let's find out the value of beta. So I get x plus 2 equal to 0. So I get x equal to minus 2. So this value becomes beta. I found out all the 3 things. I found out whether it's opening upward or downward. I found out the vertex. I found out the value of alpha and beta. What do I have to do now? Just draw the parabola. Very simple. Okay, so I'm just going to put all this in a new page, and then we will start. So it's going to be opening upward. So I can just put a shortcut here. It's going to be opening upward. The second thing is, I also found out the vertex. The vertex is 1 comma minus 9. And it is going to cross the x-axis at the zeros. What are my zeros? 4 and minus 2. So let's put everything together now. I told you this has to be x, this has to be f of x. Now it's going to be upward opening. First, let me mark 1 comma minus 9. 1 comma minus 9. X is positive, y is negative. It must lie in the fourth quadrant. So I'll roughly do a coordinate system to go all the way to minus 9. So I'll extend it here. So this is going to be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Please adjust as minus 9 here. So 1 comma minus 9 will be somewhere here, roughly. So that is where it's going to peak. Okay, and 4 comma minus 2 are the zeros. So which means it has to cross at 4 and minus 2. So minus 2 is going to come here. Minus 2 is going to come here. Which means it has to be an upward opening graph. It should pass through minus 2. It should peak here and it should go back like this. So your graph is going to look like this. Let's assume it crosses at 4. This is how the graph of the polynomial, what was the polynomial? F of x equal to x squared minus 2x minus 8 is going to look. So what type of questions can you get asked in the exam? They can give you the graph and ask you to figure out the polynomial. So you'll have to do reverse for that. Okay, so you have to first find out where it is peaking and then get the value of a, b, c. Then you will also know where it is crossing the x-axis, so you can find out alpha and beta. Those two values are sufficient enough for you to predict how the graph is going to be. Otherwise, they can also ask you a question like this. They can give you a graph like this, ask you what would be the sign of the coefficient of x squared, which is nothing but a. Since it is opening upwards, you're going to say a is positive. Okay. So these are the type of questions you can get. Now let's also take another example where a could be minus and show how the graph is going to look there. Okay, and then once we understand this, let's move into a slightly higher concept. Okay, to try and understand how imaginary zeros of a quadratic polynomial is going to look like, and then we'll finish today's discussion. Now let's take one more example. So now I'm going to take another example. Let's take this. F of x is equal to 3 minus 2x minus x squared. Now, as soon as I look at this, it is very clear to me that it is not in the form that I required, because the general form has to be ax squared plus bx plus c, which means my x squared term should come first, then the middle term with x should come, then the constant term should come. So I'll just rearrange it for my own comfort. If you want to just continue the way it is, you can, there's no problem, but I feel more comfortable putting it in the right order. So I'm just going to rearrange it and put the x squared term. X squared has a minus here, so it's going to be minus x squared minus 2x. 3 has a positive sign, so plus 3. Now after this, as usual, I'll compare this to ax squared plus bx plus c. I will notice that a this time has a minus sign, so it's minus 1. B is minus 2 and C is 3. As soon as it is minus 1, it is very clear to me that it is going to be a downward U and not an upward U. So your graph is going to look like this. Okay? Because it's going to open downwards. The next thing is, let me find out the vertex. So I found out that this is downward facing. Let's find out the vertex. I know the vertex is given by minus B by 2A minus D by 4A. So let's find out that value. So first let me find out the value of the discriminant. Discriminant is b square minus 4ac. What is b square here? Minus 2 the whole square minus 4 into minus 1 into 3. I just substituted the values. Minus 2 the whole square is plus 4. This is going to give me plus 12. So this is going to give me 16. So I got the value of d as 16. Now let me find the vertex. So the vertex is going to be, I'll just do that calculation here. So vertex becomes minus b by 2a. What is minus b? Minus into minus 2 is going to give me plus 2. I'm directly doing it. You can do the steps. 2a. 2 into a is going to be 2 into minus 1, which is minus 2. So I got 2 divided by minus 2. Minus d by 4a. D is 16. So wherever d is there, I'm going to put 16. So it's going to be minus 16 because it's minus d divided by 4a. 4 into a is going to give me minus 4. So when I calculate this, I get 2 divided by minus 2 is minus 1, comma, minus 16 by minus 4 is plus 4. So I found out where the vertex is. The vertex is at the point minus 1 comma 4. Done. Downward facing peaks at minus 1 comma 4. Now the next thing I need to find out is the values of alpha and beta, and then we'll proceed with the rest of it. This is my third step. To find out alpha and beta, I'll have to split the middle term. So I have minus x square minus 2x plus 3. This is my polynomial. I'm going to equate it to 0 because I need to find the zeros. I need factors of minus 3, that is going to give me minus 2. So it's going to be minus 3x plus x plus 3 equal to 0. So I've split it like this. Okay. Now I'm going to take a minus x common here. I'm going to get x plus 3. I'm going to take a plus 1 common here. I'm going to get an x plus 3. Now I'm going to take x plus 3 common. I'll get minus x plus 1 equal to 0. Now x plus 3 will be equal to 0. So x becomes equal to minus 3. This is nothing but alpha. Then minus x plus 1 is equal to 0. So x becomes equal to 1. This is nothing but beta. I am done with everything that I need. I got alpha, I got beta, I got whether it's downward or upward facing, and finally I got the value of the vertex. With all this in place, let us figure out how to do this. So I'm just going to write everything down here. First, what was f of x? F of x was minus x square minus 2x plus 3. Okay, now I'm plotting my graph. This is going to be x, this is going to be f of x. Now, first thing I need to know is it's downward facing. My vertex should be minus 1 comma 4, and I have 1 and minus 3 here. Okay, so let me just put all the coordinates first. 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. Done. Now let's put this together. Minus 3 and 1 is where it should cross the x-axis. So I have a minus 3 here, I have a 1 here. Okay, and the other thing I know is it's a downward facing. So my graph is going to be like this. Okay, it is going to cross minus 3 like this, come down, cross 1 and go down like that. Where does it peak? It peaks at minus 1 comma 4. Where is minus 1 and where is 4? Here. This is minus 1 and this is 4. So this is minus 1 comma 4. So my graph is ideally going to be like this. Let me put it in a different color so that all of you are in a position to see it. I'll change it to blue. I hope all of you are able to see this color. It's going to go down like this. And you can extend it like this as well. So this is how the graph for the polynomial minus x square minus 2x plus 3 is equal to f of x is going to be. Of course, I have probably not drawn this too well here. I'll just redraw it for you because it has to exactly peak there and I do not want a mistake to be made. So just make sure that it peaks here, alright? So it has to peak like this. So when you're plotting it, oops, let's do this once more. It has to be perfect. Yeah, roughly like that. Of course, smoothen the edges out. I'm drawing it freehand, so it may not look very good, but this is how your graph is going to be. I hope everybody is clear with this. Now, if you have understood this, there are a few questions that can be given as a trick factor, because with the new education policy coming into your CBSE exams, the questions are mostly going to be application, unlike some questions that had more rote learning before. So it's going to be much higher on thinking abilities. So I'm just going to give you 2-3 examples. I hope all of you understood this. Let's take 2-3 examples to understand how certain graphs might look. Okay, quadratic only. I'm not going to go beyond that. Okay, if you want to write down something, you can pause the video at any time and write it down. But here I'm going to take one more example for you. Let's take a situation like this: x square minus 1. Okay, this is also a quadratic polynomial because I have an x squared term here. The middle term is missing, it doesn't matter. As long as you have an x squared term to be the highest degree term, then that is definitely a quadratic polynomial. So I have quadratic polynomial, no problem. Now, as usual, I will do everything. The coefficient of x square is 1, which is positive, so it's going to be like this. Okay, that's the first point, done. The second thing is, let's find the vertex. I have a is equal to 1. I'm directly writing it. I'm sure all of you are comfortable. The middle term is 0, which means b should not even be there, so b is 0. The third term is minus 1, which is a constant term. Now, with all these three terms, let us find the vertex. I know vertex is given by minus b by 2a minus b by 4a. I'm sure you guys only can do it. You can pause the video and do it. I'll continue doing it here as well. I know b is equal to b square minus 4ac, which is also called the discriminant. Keep telling that every time you do it as well, so that you remember that word. What is b square? 0 square. Very good. Minus 4 into 1 into minus 1. Excellent. So I get 4. So value of b is 4. Now let's put everything together. The first term is very easy to find because my numerator is 0. Since my numerator is 0, the first term is going to be 0. The second term is minus d by 4a. What is minus d? Minus d is minus 4 divided by 4 into 1, which is minus 4 by 4, which is minus 1. You can check, you can do the calculation, but you get 0 comma minus 1 there. Very good. I found out this, I found out this. The third point is I need to find out my zeros of the polynomial. I'm going to do that here. I have x square minus 1 is equal to 0. So I'll push 1 that side, so I get x square equal to 1. X becomes equal to root of 1. This is where all of you will make a mistake. You will forget to write plus or minus 1. You have to write plus or minus 1 because alpha becomes 1 plus 1 and beta becomes minus 1. Remember, a quadratic polynomial should always have two zeros. So one is plus 1, the other is minus 1. Now I have all the values. Okay, my vertex I have, it is upward facing, and I got the values of my alpha and beta as well. So let me just, in this little space here, I hope all of you can follow, I'll just plot it here itself. So this is going to be f of x, this is going to be x. Very good. Now, it is downward, it's upward facing. I have a minus 1 and I have a plus 1. So I'm going to take this as 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Again, plus 1. Where is this? 1 second. This. So this is 1, this is 2, this is 3, this is minus 1, minus 2, minus 3. Done. Now let's plot. It has to cross at plus 1 and minus 1. So plus 1 is here, minus 1 is here. Done. My vertex is 0, comma minus 1. Now 0, comma minus 1 is here. Aha. And then it's going to be an upward facing graph. So your graph is going to look like this. Simple. Smoothen out the line. Since it's freehand, it may not look very nice when I draw it, but you people please do. This is how your graph is going to look. Now sometimes you can also have a situation like this. Now that you've understood the concept, I want you to start applying. So I'm just going to give you a few tricky questions just to think about it. Okay. The graph can also look like this. Let's assume I have a graph like this. Where this is f of x, and this is x, and let's assume this is some minus 3. Okay? Now, if you notice here, my parabola is crossing the x-axis only once. The next question is, since it is crossing only once, will this be a quadratic polynomial? A very common question people ask. Will this become a quadratic polynomial, sir, because it is crossing the x-axis only once? The answer is yes. It still continues to be a quadratic polynomial. How do I know that? Look at the shape of the graph. The shape is still a parabola. Chup chap, write it as a quadratic polynomial. Don't even think of anything else. Polynomials, if you want to guess through the graph, that can be done only by the shape of the graph. Look at the shape and tell what the graph is. Okay, tell what the polynomial is. Since it's u, this is still a quadratic polynomial. Sir, but a quadratic polynomial should have two zeros, sir. Here it has only one zero. What do we do? Think. Think. Tell me what you think it is. The answer is, since minus 3 is one of the zeros, the second zero is also minus 3. So this is a situation where alpha and beta are equal to each other and both are equal to minus 3. The next question is, sir, how is that even possible? How can I have alpha and beta equal to each other? Why not? Here, you see a minus 3, it means alpha is also minus 3 and beta is also minus 3. I'll tell you what this polynomial is going to be. If I have f of x equal to x plus 3 the whole square. Okay? What am I going to write? If I have to find the zeros of the polynomial, x plus 3 the whole square is equal to 0. X plus 3 the whole square I can write as x plus 3 into x plus 3. Because a square is a into a. So x plus 3 whole square is x plus 3 into x plus 3. And I say this is equal to 0. If product is 0, it means if I take x plus 3 is 0, I get x equal to minus 3. If I take this x plus 3 is equal to 0, I get x equal to minus 3. Now tell me, what is x plus 3 the whole square? X square plus 9 plus 6x. Is this not a quadratic polynomial? Of course it is a quadratic polynomial. Why? Because the highest power is 2. So it's still a quadratic polynomial for you. This is how the graph of the quadratic polynomial is going to look. Ask yourself if all the other parameters match. This is 1. Positive. Upward opening. Satisfies. Second point. Alpha is minus 3, beta is minus 3. So it's crossing the x-axis at minus 3. Done. The next point is, let's find the vertex as well. To see if the vertex, if you also see the vertex is also here only, because that is where it's peaking. So let's see if you get minus 3 comma 0 as the vertex as well. Now what is the formula for the vertex? Coordinates of the vertex is given by minus b by 2a and minus b by 4a. Correct? Let's put the values now. I am sure all of you know the values. Now I have, what was that polynomial? F of x is equal to, we just expanded this, right? X square plus 6x plus 9. Correct? X plus 3 whole square is nothing but this. So I have a is equal to 1, b is equal to 6, c is equal to 9. Correct? Now with all this, let's find the value of b. b is b square minus 4ac. What is b square here? 36 minus 4 into 1 into 9. This is 36 minus 36, which is 0. Excellent. So d becomes 0. If d becomes 0, this whole thing is going to become 0 for me. Let us find out the value of minus b by 2a. What is minus b? Minus b, this whole thing is going to be, b is 6, so this is going to be minus 6. Oops. Why is that not writing? Good question. So this is going to be minus 6, I just write it there. And 2a. 2a is going to be 2 into 1, which is 2. What is minus 6 by 2? Minus 3. Tada! You see? At minus 3 comma 0, it is also peaking, and minus 3 also happens to be the 0 of a polynomial. In situations like this, you people should be able to think and analyze how the graph is going to look. Only look for 3 points. See where it is crossing the x-axis, see whether it's upward facing or downward facing, and see where the vertex is. Just with those 3 points, you'll be able to figure out how the graph is going to look. Very simple logic, don't even break your head over this. Okay? This is one scenario. Okay? So one important thing you have learned is, although it might be crossing the x-axis once, if the shape is still a U shape or a parabola shape, it is still a quadratic polynomial. Let me trick you now. Let me ask you the next level question. Let's have a situation like this. And at any point in time, if you're not understanding, just pause. You can leave a comment also so that I can look into it. What if I have a graph like this? Okay? Let's assume this is f of x. This is x. I have a graph like this. Okay? Very, very interesting. Some of you might have already guessed what it is. Some of you might be still wondering what is going on. Think about it. This still is a parabola for me. It is. See the shape, it's still a parabola. So it is still a quadratic polynomial for me. They will ask you this. Is this a quadratic polynomial? Your answer is yes. Justify shape of the graph. It is a parabola. The next question is, where are the zeros? It is not even crossing the x-axis. Where in the world are the zeros? Now, it is not crossing the x-axis, I completely understand. In situations like this, quadratic equation or this quadratic polynomial is said to have imaginary zeros. Imaginary zeros are zeros that are not real. Okay? Since they are not real, they can never cross the x-axis. But it is still a quadratic polynomial. I'll take a simple example of how such a quadratic polynomial would look. So I have x square. First, to find the zeros of the polynomial, I need to make f of x equal to 0. So I get x square plus 1 equal to 0. I'm going to push the 1 that side. I get x square is equal to minus 1, which means x becomes square root of minus 1. The next question is, when I find the square root of minus 1, will I get a real answer? No, I cannot find the square root of a negative number. But you notice it's still a quadratic polynomial for me. Whenever I try to plot graphs for such polynomials, since the values of alpha and beta are not real, it is never going to cross the x-axis. So your graph is going to look like this. It's a quadratic polynomial with imaginary zeros. This is the correct answer you will give for this graph. Okay, like that. You can also have a graph like this, downward facing. So here the coefficient of x square, which is a, is going to be negative. That's the only difference. But you notice that it's even now not crossing the x-axis. Let's forget this graph now. Look at this. It's not crossing the x-axis. So the only difference here is, again, this is a quadratic polynomial whose zeros are going to be imaginary because it does not cross the x-axis. These are fundamental points I want you to remember. If you can remember this, nothing like it. The entire chapter becomes easy. Okay? I hope all of you were able to understand how graphs of a quadratic polynomial are going to look like, how you can be asked questions in the exam, how you should be able to think, analyze. If you have any suggestions, or if you want me to focus on something additional with respect to the graph, with respect to 10th standard curriculum in CBSE, please leave a message on in the comments. And towards the end of it, please do subscribe. You're going to get a lot of interesting videos from me in math and chemistry from grade 9 to grade 12. So I hope all of you are able to enjoy. Be safe and see you around soon. Thank you. Bye-bye.